So we've been studying potato chips, and we've modeled them as some normal distribution of mass with mean 50 grams and standard deviation 10 grams. We found that 87% of the bags are not defective. That is, that they fall within this range of 35 to 65 grams. That means 13% of bags are defective, and we don't want that. Suppose that we can make improvements to our packaging equipment that will reduce the standard deviation. We can't change the mean's still fixed at 50 grams, but let's suppose that we can reduce the standard deviation. And let's say we set ourselves a target of getting only 1% of bags defective. What's the standard deviation we need? So let's think about what information we've actually got. X is the mass of the bags. It's normally distributed with mean 50 and unknown variance. We've got to find the variance such that the probability that our bag is X is greater than 65 or X is less than 35, we want that to be less than 1%. So we can use symmetry again to work out what this means. Here's our distribution, our normal distribution. We got 35, 50, 65, right? This thing's symmetric, and we're interested in the shaded probabilities. So each of these shaded regions is going to contribute 0.5% to our probability distribution. So we could work out Px less than 35 is less than 0.05, 0.5%, right? And that's the same as working out this thing, right? Because both of these parts contribute exactly half the value. So we have to standardize this. Probability that Z less than 35 minus 50 over over K is now our variance. We want that to be less than 0.005. So PZ less than minus 15 over K less than 0.005. Well, now we've got a problem, right? Only the positive numbers are tabulated, and we've suddenly gotten a negative number. So we've got to, we've got to swap this around somehow. All right, so we use symmetry to rescue us once more. Right, we want that area, which is exactly starting with greater than 65, which is the alternate setup to the problem. So obviously we want 1 minus less than this setup here. So this is 15 over K, and we want 1 minus all of this. So probability 15 over K less than 0.995. All right, so what we can do is we can look up the X value in our table of standard probability. We can go looking for this 99.5. Oh, sorry, 0.995. So we start looking somewhere in this table, right? In the volume of the table, in the tabulated area, not the margins. So 99.5 appears there. It's not quite right. So we go here. It's between these two values. So you can either try and halve the interval between them, or you can just pick which one's closer. This one's a little bit closer than that one. So it's in the second column. So it's going to be 2.58. It's going to be, well, probably 2.575 will be a little bit closer, but that'll be ever so slight. Like that's a difference of 8. That's a difference of 6. So picking the midpoint, you're probably like just to the bad side of it. So I mean, I'd use my judgment. I'd go with a slightly higher value. I'd go with 2.58. So right. Oh, hang on. We want less than that value. Yeah, we should go with, let's go with the midpoint then. 2.575. So if x is this value, we can now solve for k, right? We're just solving this equation here. So k, the variance, must be equal to 15 on 2.575, right? And if we did that on our calculator, we would find it's equal to some awful number. 5.83, close enough. All right, so if our variance is this, or sorry, our standard deviation is this, then we would only end up with about 1% of bags being defective.